Hello everyone, welcome back to our channel. Today we are back with one more string problem that is there on in blind 75 SD sheet. So the problem name is minimum window substring. Okay, let's read the problem statement. So we are given two strings. String S is of length m and string T is of length n. Okay, so now let's see the task. Our task is to find the smallest substring in S that contains all the characters of T, including the duplicates. If there is no such substring, we have to return an empty string. Okay, so I have taken the example from the LeetCode itself. So string S we have been given string S, that is this code bank. So T is equals to ABC. So we have to find what we have to find is basically we have to find the smallest substring in S that contains all the characters of T. So in T we can see ABC. So in output it is obvious that ABC should be there. So ABC is there. So in explanation part, basically we can see BANC is the smallest substring in S that contains A, B and C. Similarly, we can see in example 2, we have been given an input string that is S is equals to A and T is equals to A. Here the output will be, it's very obvious that output will be A only because both the strings are same. So the entire string S is the minimum window. So we can return the output as A. In example 3, we can say that input string is A and T is equals to AA. So we can say that there is no such a substring which is similar to T. So we can return an empty string. So explanation is basically T requires two A's, but there are only one in S. So I hope you are you got the problem statement, basically what we have to do. So in this problem, so let's think of the brute force approach, how we can do it. I will explain you both the brute force approach and the optimal one. So be there till the last of the video, you will get the solution. So the brute force approach involves checking all possible substrings of S and verifying if they contain all the characters from T. This is very naive approach. Okay, anyone who is dealing with the problem first time will think this way only, and it's obvious. So the algorithm is basically generating all the substrings of S. Okay, and we have to check if each substring contains all the characters of T or not, and then we have to keep track of the minimum length substring that satisfies the condition, and then at last we have to return the smallest valid substring. Okay, so we can do we can do this, we can follow this approach, but the time, let's see the time complexity for this approach. Basically, to generate all the substrings, we will be, the time complexity will be O of m square. Okay, basically length is m and it will be like O of m square substring, the time complexity, and after that checking if each substring contains T takes O of n time. So the total complexity will be like greater than O of m square, like we have to multiply n also. So O of m square into n. So this will be like exponential growth for the large inputs, right? And space complexity is basically O of n for storing the T count and O of m for storing the current substring. So space complexity is also O of m plus n. So drawback is basically it's clearly visible that it is inefficient. The solution is inefficient for the larger inputs. Okay, so we have to think of a optimal solution, right? So let's move towards the optimal solution using the sliding window approach and the two pointers, right? So what we are doing is basically to improve the efficiency of the solution, we will use a sliding window technique with two pointers, that is left and right, along with a frequency count. So our idea will be like we will expand the right pointer until the window contains all the characters of T. Okay, and we will shrink the left pointer to find the smallest valid window. And after that we need to keep track of the minimum window found. Okay, and algorithm is basically simple if you think of it by own also. And if by seeing the idea alone, you all can make the algorithm. It's easy. Basically, we will use two pointers, left and right, and we will expand the right pointer until all the characters in T are covered. Okay. And after that, we have to shrink the left pointer to find the smallest possible substring that is valid. Okay. And after that, at last, we have to keep track of the minimum length substring found. Okay. So let's see the try run of the optimized approach for this question. Basically, the example we can see this. It is similar to the problem in the problem statement. I already discussed it. Basically, S is this and T is equals to ABC. So in step 1, we are initiating the left pointer as 0 and right pointer is also at 0, and window is here only A. So formed until now nothing formed. So we will expand. In step 2, we will not increment the left pointer. It will be at 0 only, but we will increment the right pointer. So window will become like AD. Okay, it will again. Basically, we need to expand it again. So again, in the third step, we are not expanding the left. It is only that 0th index, so it will be 0, and we are expanding the right pointer, that will be 2. So again, this time the window will be ADO. Okay, slowly the right pointer will gradually move in ahead. Basically, you all can see ADO, then ADOB. Okay, then ADOBE, like this we can say, then ADOBEC. After that, what we can do is basically after ADOBEC, we have like ADOBEC, left will be at 0 and right will be at 5, and there will be three characters already there, like ABC is there in this ADOBEC. Now we have to find the smallest one. Okay, so as soon as we get the ADOBEC, like 3 strings are we got it. Okay, now it's time to see the smallest. So now what we will do, we will not expand further, we will contract. Okay, basically we will shrink the left pointer. So it was at 0, but from now on, since 3 characters are formed, like ABC are formed, so what we can do is we will shrink the left pointer. Like, so what will happen is basically it will move, the left pointer will move ahead of A, that it will come to D. So you can see that DOBEC. Okay, again 3 are getting formed. So again it will shrink, then it will come to OBEC, then again 3 will be formed. Similarly, OBECO, this time 2 will be formed, but the characters are 5, but we have to take the smallest window substring. This time we are at last, step 10, we are having BANC, that is the smallest, and here we are getting all the 3 letters, that is ABC, and that was there in T. So this time we can update the minimum length. Okay, so final output will be BANC for this. This time the time complexity will be O of m plus n. Basically the right pointer moves O of m times and the left pointer moves O of m. Then again each character will be processed at most twice. Okay, so total will be like O of m plus n. The time complexity will be O of m plus n, and space complexity will be O of n for t count and O of m for window count. That will be, it will be same as the time complexity. So the space complexity will be also O of m plus n. Let's see the code, how we are implementing the solution. Basically what we did, I will show you. There is a function min window, and string s and string t are getting passed here. Basically base case is if t is larger than s, so it's obvious no such window can exist. This is the base case. If this base case is not getting satisfied, straight away we don't need to check anything, we can return empty string. So okay, this is the condition. Then we have frequency map for character in T. Basically for checking the characters, or checking the characters in T, basically we are using unordered map, that is key value pair character in int. So this was for character, checking the characters in T. Again we are having frequency map for characters in the current window. Okay, similar thing. Okay, then we have 2 pointers for sliding window. Basically left and right, we are initiating it to 0. Then number of unique characters in T that need to be present in the window, that we have to take, like we have taken the required variable and frequency dot size. After that we are having the number of unique characters in the current window that matches the required frequency in T. So we are taking the formed variable, int formed is equals to 0. Again we have to track the minimum window, so we are taking min length is equals to int max, so we can compare it later on. Okay, and min left is equals to 0, we have initiated it. Now it's time to expand the window by moving the right pointer like I was doing in the dry run. Okay, so basically after that we have to check if the current character's frequency matches that in t. If it matches, then we have to increment the formed variable we have initiated here. Like it is unique character, we have to increment it. Okay, basically after that we have to contract the window from the left as long as it remains valid. Basically this is the condition you all can see, and we have to update the minimum window if the current one is smaller, right? This is the thing. As I shown you in the dry run table, you all can relate it with that. So after that we have to correct, what we have to do is basically the character to be removed from the window, basically unnecessary, the extra character. Okay, then after that if the remove character was a part of t, then its frequency falls below the required count. Okay, if and we have to after that we have to increment the left pointer, otherwise we have to move the right pointer to the right to expand the window. Okay, and it's obvious that if no valid window was found, we have to return an empty string. Okay, and after that at last we have to return the minimum window substring, that is return s dot substring minimum left or minimum length. Min length we have declared it as int max, now it will compare it with this. So this was the code, and now I will explain you a bit about how everything was happening in the code. Basically there was a base case, if the length of t is greater than s, it is possible to find such a window, so we return an empty string. After that there is a big use of frequency maps here. We use two hash maps. Basically t frequency counts the frequency of each character in t, and window frequency, that is counts the frequency of each character in the current window of s. Okay, and two pointers we use for left and right. Basically we initializes two pointers, left and right, both were starting at the beginning of s. These pointers define the current window in s. Okay, required and formed are the two variables we use. The number of unique character in t that must be present in the window was stored in required variable, and the number of unique characters in the current window that have the desired frequency as in t basically was stored by formed variable. And we also introduce the expand and contract window, that is we expand the window by moving the right pointer and updating the frequency of current character in the window frequency, that is variable, and if the frequency of the current character matches its frequency in t, we will increment the formed. Once the formed equal required, it means the current window contains all the characters of t with the correct frequencies. Guys, you have to relate it with the, basically I have written it in a very simple manner. The problem tag of on the LeetCode for this question is basically hard, but by writing it into a simpler manner, the problem seems to be a bit of easy level, because there is nothing too much extra in this question. Just we have to think of the approach and implement it, just sliding window and two pointers. After that we then try to contract the window from the left by moving the left pointer to find the smallest possible window that still satisfies the condition. Basically what we are trying to get as output as minimum window substring, so we have to keep track. Okay, after that at last we have to update the minimum window during the contraction phase. If the current window is smaller than the previously recorded minimum window, we will update the minimum length and min left to track the new minimum window's length and starting index. Okay, for returning the result, we have to compare it with, if the min length remains int max, it means no valid window was found. So basically we have to return like empty string. Otherwise we will return the substring starting from min left with length of min len. Okay, which represents the minimum window substring containing all the characters of t. Okay, this approach will ensure an efficient solution with a time complexity of O of m plus n. As I already discussed with you all, this how everything is, how time complexity is O of m plus n. Basically the space complexity will be also O of m plus n only for this question. So I hope I was able to clear this solution. If you understood the solution, please hit the like button and also share it with other students as well. Thank you.